I just had a discussion with Kumar Ramaswamy and Jeff Cooper from igolgi, who is a maker of encoding products at the broadcast side for broadcasters. It was a very interesting conversation because the both of them had worked on the ATSC 1.0 standard back in the 90s when it was being developed. Jeffrey worked on the video compression side of things, and Kumar worked on the underlying physical layer 8VSB. And we go into a lot of topics in this discussion. We talk about how 8VSB was compared to OFDM back when ATSC 1.0 was a brand new standard, and all of the things that, came up with. Is 8VSB better? Is OFDM better? Second, since their company igolgi is behind the deployments of the H.264 encoding at all of the broadcast sites owned by Bridge News, we discuss their H.264 deployments with ATSC 1.0 and everything that they had to go through to make sure that that actually worked, because I was surprised. They said that there were at least 3 different ways in order to ensure that a wide range of TVs would actually be able to support H.264. So it's not just as simple as, okay, let's just start sending H.264 out. You have to signal it so that the TV actually knows what the codec is. We also got into some future video coding type stuff. I brought a little prop with me here. I brought my cheap Android phone and showed that a VVC encoded file with a very short GOP could play back with software perfectly fine at very low bit rates. They themselves have created many patents, so it was an honor to bring them on and bring their expertise into this discussion. So anyway, without further ado, here's my interview with Jeff and Kumar. I really appreciate you guys coming on. If you want to introduce yourselves.
Hi, Dylan. Yeah, my name's Jeff Cooper, and I'm a co-founder at igolgi, working with Kumar.
Yeah, I'm Kumar Ramaswamy. As Jeff mentioned, Jeff and I spent a long time together at Thomson RCA, and then started igolgi back in 2008. And we've been serving the industry since then.
Both of you guys have a long history with the original ATSC 1.0 standard. I know Jeffrey worked with encoding and Kumar with the modulation and the RF and the physical layer side of things. So if you guys just want to do a brief overview on your time with the original 1.0 standard and everything that you learned during the time, and if there was anything especially pertaining to 8VSB that you'd like to share, I'd love to hear what you guys have to say with that.
Sure. We were both young engineers in the early 90s, really right out of school pretty much for both of us. And we were both working at RCA Thompson in Indiana at the time. And so this was during this period, MPEG-2 was still in development. The standard was still going on. There was an effort, driven by the FCC to develop a digital TV standard. Of course, up to then, it was still analog. And so a lot of new technologies were becoming possible to do for the first time. It really was a period of transition from the analog television world to digital world, not just for broadcast, but satellite and things like DVD were just behind this, in the early mid 90s and things like that. So anyway, my part of it was on the compression side. I was working on the we called it MPEG 1.5 at the time because MPEG 2 wasn't quite done. And we Thompson meaning worked with partners, David Sarnoff Research Center, Philips, and NBC to jointly design a system that was one of the systems tested by the FCC, which pieces of came from different people like groups like that to form what became the Grand Alliance. Most of the systems had a lot of similarities, digital compression for the first time. And Kumar can speak to the modulation, which is where he was working.
So, Dylan, we had just completed satellite deployment of DirecTV satellite, which was the first back in the early 90s, right? 93, 94 was when satellite deployment had happened. bring digital television to consumer homes. Closely following on the heels of that, the Grand Alliance was trying to standardize terrestrial broadcast in the United States. And on the physical layer side, as Jeff mentioned, the Grand Alliance had about 4 or 5 companies, large companies for large consortiums that brought technology to the table. We looked at single carrier modulations as well as multi-carrier modulations, because in Europe, a lot of the systems that were being developed and considered were multi-carrier. It turns out that given the geography of the United States, single carrier, because they are far spread out, the transmitter distances were much further apart. The geographies were such that single carrier modulation got us the maximum coverage. And in fact, the Zenith's modulation system that was tested against all the other modulations, including multi-carrier, including something developed by General Instrument with the single carrier QAM system, as well as the VSV system from Zenith. Zenith actually won out on all the points. When they did a matrix of, they had a rubric on which they looked at coverage, performance, and multipath performance, and all the various elements. Zenith system won out. So it turns out that given the broadcast infrastructure, the analog transmitters that existed back in the early 90s, and the overall broadcast infrastructure of the United States, the single carrier modulation system at that point made a lot of sense. And that's why the Zenith system won out. You'll hear a lot of talk in the industry about, hey, we should have chosen multi-carrier. The Zenith system wasn't ideal. 8VSB wasn't ideal, but actually that is not true. It turns out that we spent about 2 years doing measurements across the country, doing physical measurements to see performance of all the systems that were developed at that time. And Zenith won out quite handily. And it has served us well over the years, except that in the last 25 years, the broadcast infrastructure and the cellular infrastructure has developed in the United States. And now we have a very much richer location base for setting up transmitters. And so maybe now multi-carrier modulations with single frequency network infrastructures makes a lot of sense. Back then in the 90s, it did not make sense. Actually, the Zenith system was the right answer for that time. And bringing together both video compression for the first time, like MPEG-2, as Jeff mentioned, and this whole digital modulation system, that's what made digital television possible. And it has served us well in the last 20 years. And now it's time for a change, and which is why ATSC 3, which chose a multi-carrier modulation system, is actually will stand us in good stead in the coming decades.
Well, yeah, and I'd like to just touch on that briefly. So back in the 90s, one of the main things that at least I've seen as a way to make 8VSB look better is the fact that it required less power. Mm-hmm. A multi-carrier system is going to utilize more power, and it's also more computationally complex. Mm-hmm. Obviously nowadays we have LDPC, we have non-uniform constellations. There's all of these things that have made that basically irrelevant. The power mm-hmm. argument is just completely thrown out the window now, because you could obviously utilize, more efficient, modulation techniques to drive that power down to, serve the same mm-hmm. amount of data capacity. But what's interesting is in 1999, I believe one of the hallmarks of that movement was from Mark Atkin, mm-hmm. who was talking from Sinclair at the time with the FCC. He wanted to, and at least representing Sinclair at the time, he wanted to move towards OFDM, and they saw that OFDM, even back in the late 90s, perform better with multipath. So it's interesting that you said that with multipath, 8VSB, if you'd like to elaborate on that a little bit.
In certain geographies, that was true. For example, I think a lot of the testing that Sinclair was doing is in the Northeast corridor, where first of all, the transmitter spacing, single frequency network transmitter spacing was a lot closer. But if you went to the west side of the country, where the spacing of transmitters was much further apart, OFDM systems weren't efficient at all. In fact, for us, the way to think about it is the amount of power that you put out, what population coverage can you get without interference. It turns out that the Zenith single carrier modulation systems for open geographies actually gets you better coverage for a given amount of area it did give better coverage. And so it's also dependent on the geography of the country. This is why COFDM was so much more successful in European countries, because their transmitter locations were a lot closer, and you could treat signals from two transmitters as essentially multipath and equalize it out on a receiver and things like that, and you could place transmitters close to each other. Yeah, unfortunately, that kind of density is not applicable to the United States, and which is why at that time we found that the single carrier modulations did, for the amount of power you put out into the infrastructure, it gave the best population coverage. I'm quite familiar. I know Mark quite well. We have worked. In fact, he was in Thomson before he went and worked for Sinclair. So, the technical arguments actually do not hold merit. Back in the day. Now with not just the LDPC coding, it's or OFDM modulation. It's also the fact that you can in fact now rethink how transmitter infrastructure, the location of transmitters, because of the cell network that developed afterwards, the location of transmitter antennas can be completely you can rethink that completely compared to where it used to be back in the 90s. And so given now's OFDM does make some sense.
Yeah, and I'd just like to say one last thing about this. I think it's kind of almost a little ironic that 8VSB was chosen for coverage when in reality what ended up happening is mainly in 2009, there still is a huge populace in this country, this huge portion of the population that believes that over-the-air TV ceases to exist as soon as analog television got brought off the air. So obviously, I understand that at the time, I think mainly the modulation was limited by the code because MPEG-2 was only so capable. And if you were able to utilize more robust modulation at the time, there wasn't really any code that would really allow you to do that at any sort of meaningful scale, especially with MPEG-2 at like 480i. It just wasn't really possible. And I bet Jeff could elaborate a little bit more on that. But, as far as like the population coverage, it was still very bad, and it still is to this day very bad. And that's one of the reasons why I like ATSC 3.0, and I kind of advocate for, I don't know if you see a bunch of my videos where I, talk about receiving channels with a paperclip. I'm doing that on purpose because I want to kind of push, the notion that like broadcast should be super accessible. And we have the technology to do that now with, more lower modulation and code rates, more robust transmissions, and everything that we can do to make that signal really, really robust. So that is unfortunately what we didn't have in the late 90s. We can really, really bring that now. And I would love to see that in this country and potentially have people that were even able to receive NTSC broadcasts, for the first time with ATSC 3.0, if it's sent, more robustly.
So that's a nice, segue into the type of discussion we want to lead into. One of the challenges, as you probably are well aware, is in 3.0 is it's a chicken and egg problem, right? Yeah. So as you start developing, you need to have a certain density from a business perspective. You need to have a certain density of receivers, a certain number of receivers before it starts for broadcasters to make sense to do the conversion. And it's a chicken and egg problem. Consumer electronics manufacturers say, hey, why should I put an ATSC3 tuner in the television set since there is not enough programming to watch? So, and it goes on in cycles, right? And it has gone on for almost 10 years. That cycle has kept up back and forth. So our contention is that in the meantime, while this is getting pushed out, and by the way, Jeff and I, about 8 years ago, we went to NAB, 7-8 years ago. This was well before COVID. And we introduced an ATSC3 encoder in the market and the whole chain, the signaling chain. The problem is since then, we have only sold 15 stations on it. We haven't sold, there are 3,000 plus stations. And we, as a company, have not been very successful in pushing ATSC3. And we think the reason is exactly the cycle that I talked about. So then about 4 years ago, we started to say, hey, what else can we do so that the interim, keep the broadcasters on air and get them more efficient, which actually is the reason why we introduced MPEG-4 into ATSC 1.0 to try to get additional programming, because a lot of programmers, a lot of station owners are complaining that they could use additional bandwidth. They said, we like ATSC3, but hey, I wish I had additional capacity in my ATSC1. So we said, hey, you don't have additional capacity, the bandwidth will be the same, but we can put in more additional programs by converting to H.264 or MPEG-4. By the way, that's supported by the standard since 2009. So this is why we kind of went in that direction. And one of the big things that maybe Jeff will talk about is our mixed mode statmux that we developed in order to enable this to happen. So Jeff, you want to talk about?
Sure, I can discuss that. And just to add to what you were saying, I mean, even with H.264 and ATSC 1 and our customers, meaning the stations wanting it, they still had the chicken and egg problem. That is, even though it was part of the standard, and even though there were TVs more and more having H.264 in it, the stations and the content owners who had their content being broadcast on those stations were very concerned for years, until really just about a year ago, that they were going to lose too many viewers by switching to H.264. They were going to be concerned about older TVs not working with H.264 yet, since the original ATSC 1 standard only had MPEG-2 in it. So that has been one of the things that has held just H.264 getting used, let alone the big chicken and egg problem with ATSC 3. So anyway, we really believed in getting H.264 out there. The benefits over MPEG-2 are roughly 2-to-1 in compression efficiency, and on top of that, H.264 has a lot of compression tools in it, if you will, that kind of clean up the video a little bit more. It makes it extremely clean picture, less artifacty, with things like deblocking filters in it. So beyond the more channels, the pictures look better. And so, we started to develop, an ATSC 1 encoder, feature with H.264 in it. And then we quickly realized that our customers really wanted both. They wanted to be able to do some MPEG-2 channels and some H.264 channels, because especially maybe their .1, their main channel that they might have on air, to really protect their viewership for that, they wanted to keep that in MPEG-2 and do maybe everything else in H.264 or some other combination. And so over the years, we had already had what's called a statistical multiplexer in our MPEG-2 ATSC 1 encoder, and we realized that, well, if we isolate the MPEG-2 encoding in one statmux pool and the H.264 encoding in another statmux pool, it's going to be less efficient. We're not going to get as many channels through the system as if we can mix them all together. So we developed what we call mixed mode statmux, so that all the channels are statmux together into one pool, and you really get some great efficiencies from that. And statistical multiplexing is simply where you allow the bit rate per channel to vary with the content complexity, so that you're not wasting bits on a channel that may not have as much movement or action in it in a given moment. And then you can take those bits and use them in another channel that might need it. And by doing that, you can get about 20% roughly more efficient compression. So that really, that turns into a couple extra channels sometimes, or just more improved quality.
Yeah,
So
and there's an art to it too. I mean, I know you've talked about Anton Capello with me and what he did at his station. He was able to push the limit with statmux, and able to achieve these very high quality looking video streams with very little data capacity required.
Mm-hmm. That's great. So we got that into the market a few years ago, and we still had this, concern from broadcasters, our customers. We had a few channels, a few stations who started just barely using H.264, just turning on a channel or two, and starting to grow it a little bit. We had a few stations who were doing, up to almost 20 channels, and they were being successful. And so this finally started to break the problem open, that people realized that, hey, since about 2012, every TV can decode this H.264 now. and some of them even before that. So we're beyond, more than 10 years past that point, and the way that consumer electronics and prices have come down, the people buying TVs more frequently because they're so less expensive and things like that. So the population coverage for H.264 had really reached that critical point, and we finally got some larger station groups to say, "Hey, we're going to go for it." And the biggest one was last year. Bridge News worked with us, and we did their whole nationwide station coverage, which is about 80 stations in H.264. And right now they're on the air with 16 or 17 H.264 channels across the country, and just a handful of phone calls from, there's still one or two people out there that, hasn't changed their TV in 20 years. But in general, we were joking around with some people at NAB, anybody who calls who doesn't have a TV that works, some of the stations go and buy one and give them to the person. So it's that, low a percentage. So we were thrilled with that, and thrilled that it's finally going out into the market. We saw a lot of interest at NAB just 2 weeks ago.
There is one interesting challenge that we had during the deployment in the early days of some of these H.264 deployments. Some televisions, even though they could receive streaming H.264, they could not receive the over-the-air. It turned out that the way you signal in the stream, there are multiple places in where you can signal that you have an H.264 codec instead of an MPEG-2 codec. So about 5-7 years ago, some people did early trials on 264, and then they came out with publications saying that, hey, half the people don't receive television using 264. It turns out that's actually, the reason was because the television actually did not recognize the fact that you had an H.264 stream. And there are multiple ways to signal that. There are at least 3 known ways where you can signal the fact that you are carrying an H.264 codec. You can do it in the transport stream, you can do it in the header, you can do it in auxiliary data. And different television manufacturers are looking at different spots to see, do I have an H.264 stream or an MPEG-2 stream? So if you didn't cover all your bases, you are missing some of the television sets. And we discovered that after about a year. We got specific televisions were not picking it up, and then we would buy those televisions, bring it to our lab, and then figure out, oh my God, it's looking at a different spot in the stream to look for the codec. So we covered all the bases. We kind of let everywhere where we can tell the television that it is a H.264 stream, we put it in. We put those flags in. And then that coverage vastly improved, right? Now we hardly get anybody with a 2012 or 2013 television, anybody beyond that, we hardly get any complaints that they are not able to receive the audio. A lot of times what would happen is they would receive the audio but not the video because it didn't recognize the codec. So we have plugged all those holes, and now we believe that we are well above 90% of the people who have a newer television set, they should receive all the streams just fine. And so that's actually improved a lot in the last few couple of years, especially with Bridge. Bridge has got, as Jeff mentioned, we set up their entire infrastructure from Detroit. And the other thing we did, the other big innovation we did was to make it, we built a centralized data center with a nationwide distribution that really helped their operations, including conversion to H.264. If they wanted to do some, channel lineup changes, all that became really simplified. And when they rolled out the system, we have had very, very few complaints. And by the way, the other interesting thing that we do is in the MPEG-2 channels, we tell television owners, please scan your television set this weekend, because we put a scroll, public service announcement that tells customers that please rescan your television, because you may be picking up a few more channels. Because if you start a broadcast of H.264, you have to rescan the television for the television to recognize that these channels exist in the guide. So we did that public service announcement in all the cities. We were doing it once a week, sometimes 3 times a week, just to let people know, hey, rescan your television, you may pick up a few more channels. And that helped as well, actually. Those 2 things really has changed the game for receiving, with the ATSC 1, receiving the channels on existing television sets.
Yeah, my 2018 Samsung TV didn't even need a rescan. It just...
So it didn't need a rescan.
Yeah.
Wow, that's pretty cool.
I just turned on the TV, popped the channel, and it just instantly knew to start decoding H.264.
My bet is their software, right? They are probably doing a periodic scan in the background that
Yeah.
looking for the guide. They update the guide. Some older television sets may not update the guide, or even if they updated the guide, they may not know to look for a different codec, for example. So you're right. I mean, so what we discovered was the PSAs helped as well. In Texas, we have a customer who runs 20 channels, all SD. Okay, he's running all 20 SD channels. He told us that he runs, even now, after several months, he's still running public service announcements once a month to tell people, hey, rescan the television. You may be picking up a few more channels. And guess what? Some customers did tell him that that did happen. So it's it's an education as well, right? In addition to
Well, it's
yeah.
also hard, how well the hardware at the consumer side is working, just
Yes.
like you mentioned. The Samsung TV's got some smarts in that and
Yes.
underlying software to do that. Your budget TV from 10 years ago may not have that
May not have.
functionality.
Exactly.
So,
Right.
And the other interesting thing is that I don't know if you know this, the newer television smart TVs have another very nice feature in that if they have a streaming service and you have an off-air antenna, they kind of create a common guide where they show you all the streaming channels, all the fast channels, and the over-the-air channels, all in one guide. So, and they pick up all the new channels as they come along. So they just add it, tack it to the bottom of the streaming guide. So you can go through the guide, pick up your streaming channels, you can pick up off-air channels also, including the sub channels. It's pretty cool, actually.
the only thing that I don't like about that, though, is there are some people, typically people that don't know how the technology works very well, maybe older individuals
Yeah.
who think that all of those channels are coming from an antenna. That
Yeah.
if they're using an internet service provider that has a data cap, or
Oh, they start using it a lot.
or their internet went out and they're like, wait a second, why is my antenna signal out? I should be getting this is antenna, right? So for some people it does add some confusion, and that's kind of my little bit of a bone to pick with some of these ATSC 3.0 internet channels. Is it's like, isn't the whole point of broadcast supposed to be that you don't need the internet? But that's my thing. But it does make it very convenient, and I think the Pearl TV and the next gen TV kind of consortium is doing that with 3.0 with these internet channels, kind of on their own hardware side, and not just with the end consumer devices doing that themselves with their own, like Samsung TV Plus is an example. I just want to say that for the one TV in my video that I did with the H.264 testing with the station in Buffalo, New York, that TV wasn't even able to receive the audio. So the audio wasn't even playing, and it's just standard AC3 audio. So there's something in the logic of that software that's just not accepting.
Which television set was that?
It is a brand that is no longer making TVs. It was made in like 2008. It is Aria, which doesn't even make TVs anymore. It
So
is
the
an
Aria, I
artifact
know,
on our
okay.
wall.
The problem is, I suspect in 2008, right, their software probably didn't even recognize the fact that it probably thinks it's an unknown codec or something like that, some error, and then it just errors out probably.
Yeah.
Because the standard was standardized in 2009 or 10, if I remember correctly. And then since then, most television sets included it, and streaming started to appear in 13, 14. So most television sets by that time frame started to say, hey, 264, no big deal, right? I can just use it and play it. They had software drivers to just play it. So it's been, I would say that anything beyond 2012, 2013, we should feel reasonably, except we found one Samsung set, right, Jeff? I mean, in Pittsburgh that consistently, the funny thing is that a year before that was playing fine, but the year after that was not playing. For some reason, it was having trouble, but we never figured out why.
Yeah, that was a 10 or 11-year-old set, I think.
Yeah, it was 11-year-old set. 2015 set was not playing. 2014 was playing fine. So,
yeah, the oldest Samsung TV sets that we have are 2014s. So
they play fine.
Those are playing fine.
Yeah, try a 2015. I think a 2015, we had a problem with the 2015. 2014 was good.
Really? Maybe it's like a low end model, or maybe a model that was, who knows? Who wrote the software at the time? Who knows?
Right.
Yeah.
Right. Yeah.
But it's actually funny because Bridge News operates 2 stations here in South Florida, where I'm at right now in Miami. Both of those I cannot receive here for various reasons. The first one is on the low VHF band.
Oh, I see.
I have a low VHF antenna, and I'm covered by OTARD. The over-the-air reception devices rule to have this ginormous thing in my apartment to receive a local TV station that's only 9 miles away. and I still can't even receive it.
Huh.
And, that's going back to 8VSB and especially time interleaving, which is a major problem. It is just such a different world now that we live in with all of
Yes.
these cheap electronics from Temu, from Alibaba, that, I mean, half the stuff sold on Amazon now, I'm sure isn't passing some sort of FCC regulatory check for emissions on RF interference. And it's gotten to the point where when I was in a dorm room, now when I'm in an apartment, the VHF band was just completely unusable. The high VHF band was okay. The low
The
VHF
low V has
band,
got, there's a lot of other devices that are probably just blasting all over the place. You're
oh
absolutely
yeah,
right.
it is. I mean, all you have to do is take a spectrum
Yeah,
analyzer
yeah,
and
easily.
just,
Yeah.
it is insane,
Cool. It's
which is
insane.
why I'm personally advocating for an ATSC 3.0 mandate on the low VHF band specifically, because I personally believe that the FCC should mandate solely either HTI, hybrid time interleaving, or extended time interleaving
Sure.
with a maximum of like 16 non-uniform QAM and relatively lower code rates. Otherwise, you're not even serving the
All
public.
it meant to
That's
say, yeah,
my
sure.
opinion, because your population is not going to be able to receive anything. I'm
The
90
other
miles away.
alternative is to completely do away with VHF, right? Just stick to UHF for above a certain band for all your television, broadcast television needs, and reassign the low UHF to something else, because it is very interference prone, very, very. And especially when people don't want to put up big antennas, they don't want to put up, the VHF antennas. So, I mean, it's time to think about that too. I mean, in ATSC 3, for example. So,
Well, I think for me, it's, low VHF does have some really good properties, especially
sure.
in rural
Indoor.
communities with
Mhm.
mountain ranges and hills, and especially forested areas. It works better with multipath,
Sure.
just as a, longer wavelength. So, I want to personally keep it around because, there's going to be areas, in the boondocks in these very hilly areas that won't be able to get UHF even with QPSK,
Mhm.
in an extremely low code rate that would if it was hot if it was low VHF. And maybe, does that require that person out in the middle of nowhere to have, a low VHF capable antenna? Maybe it doesn't have to be. Maybe it can be less tuned or not as good for the low VHF band and
Mhm.
still be able to, provide some sort of usable service to them. And that's why I personally kind of want to keep it because
No,
I
but
do.
the FCC can regulate that, right? They can do rural spectrum allocation can be done where the rural areas can get the VHF allocations, and urban areas there is no point in making VHF allocations for two reasons. One, by the way, long time ago, I was talking to the FCC about exactly this topic, that urban areas, because of all this interference, VHF is becoming, and plus people don't want to put up bigger antennas in urban areas anyways. So,
Yeah.
so what is the point in allocating? You can do something else with that band, but this is FCC's spectrum planning is very opaque, I must say. Yeah, yeah.
Yeah. If Jeffrey wants to add anything to just the general coding talk about lower modulation and code rates, I'd love to hear what he has to say.
On compression, I mean, of course, we'd love to get to the next generation of codecs. We are, H.264 has been a great breath of fresh air, and it's the most widely supported in consumer devices and TVs now. So we're really happy to have it. Obviously, ATSC 3 has got HEVC and VVC in the standard now, which gets you, especially for HD 4K, and it really has a big improvement in compression efficiency. Those codecs lose a lot of their benefits with lower resolutions. There's still benefits, but it's not nearly as much, especially up at like 4K. But again, we have this problem. The devices aren't there. Even HEVC is only in high-end sets. It's a very small percentage of the overall population out there right now. So you certainly can, technically we can do it, and we'd even love to do it in ATSC 1, and I know there are some people experimenting with that, but it's really not part of the standard, and uh, you know. So it's difficult for stations to take that next leap. I think they're really wanting to to get, have ATSC 3 to get to those next codecs. But obviously with those, we can get another, improvement in picture quality, especially going up in higher resolution and, or even more channels. The sky's the
Yeah.
limit almost.
And I'd like to talk a little bit about your Lux encoder, I believe it's called, for the solution. It said on your website 24, up to 24 possible streams of video. I'm curious, is that a software limit? Because in theory, you could compress things further. You could have, 35, 40 in theory if you really wanted to add some compression. If obviously there's limitations with the iframes and, how much you can save,
Sure.
but
So that's really based on H.264 and SD, right?
okay.
That's what we can get with our statmux advantage, that helps squeeze in even further. But that's like we said, we have one customer in Texas doing 20 channels. Bridge News is at 16 or 17, and they're
Going to
adding,
20.
will be adding. So 24 we've run in our lab. We don't know anybody who's doing that yet out in the field, but it's practical. And then if you wanted to go beyond that in SD resolution, you'd need a next generation codec.
So one of the problems you also have, Dylan, is that the overhead of PSIP and audio starts to eat into your each channel now. All of a sudden, you need 64 to 128 kilo, at least AC, since it's AC3, you need 128 kilobits of audio for every channel, right? If you start doing more than 24 channels, that you're already eating up 5 megabits or 6 megabits just for the audio alone. And then PSIP data for each channel, you need to have about 150 kilobytes or kilobits per second of PSIP data to describe the channels. When you add up all that, right, all of a sudden you're eating into, you can't do, even if the video codec can support a few more channels, the audio overhead and the PSIP overhead and everything starts to add up at that level. And what we discovered was getting beyond 24 SD channels, SD good quality. And you must have seen the video in our in your Buffalo station. There will be some talking heads which are very easy to code, very low bit rates. The video is coded at very low bit rates, and each of them can be individually set. And if there is a little bit more higher action channels, we give it more bit rate, higher bit rate, average bit rate settings, and things like that. Even when you do play all those games, when you get beyond 24, we found that it's pretty hard. You're pretty hard pressed to add more channels. So the limit is imposed by the fact that you have 19.38 megabits per second that you have to allocate between all these guys, including audio and PSIP. And that starts to eat in. The audio and PSIP starts to eat in,
Yeah, when I did a TS reader scan with that station in Buffalo, everything was around a megabit per second. And what's interesting is there were stations from Tegna and Nexstar in the same market that had MPEG-2 video at 700 kilobits per second. So that's where I'm getting at with, in theory, more could be done. Obviously, is the picture quality going to be fantastic? No. But if you tweak some things, if you do an Anton and you sit there and
yeah.
it depends, on how much, effort you want to put into the statmux. But, I was kind of surprised. I'm like, man, they're allocating some decent data capacity to these streams.
Yeah. Oh, they were doing MPEG-2 at 700 kilobits per second?
Yeah, it was ranging from 700 to 900. And that was on a Nexstar station. The video quality was bad, but it was watchable. And I can send you the TS reader.
Sure. What did you think of our MPEG-4 quality? Was that watchable?
So what I did, and fundamentally, this is, in my opinion, a little bit of an issue because I like comparing the video quality to what is available if you were to watch it directly, because most of these channels are fast channels that you can watch on their respective website or on Pluto TV or Plex Free TV and some of these fast, free outlets. And, I think I saw that on the, what was it? One of the sports channels, it was beIN Sports Extra, the beIN Sports Extra and beIN Sports Extra en Español. Both of those were around 1.8 to 2 megabits per second, 720p on, on the website, on their respective website.
Sure.
Where with yours, it was like ranging to like 1.1, 1.2, and it's not that far off. And I was just doing this thought process in my head. I'm like, technically you could get that compression down a little bit more. And what if you did make it 720p? Because I've noticed that with all of your, encoder type, stack that you have, it seems to be limited to like, oh, you can only do 4 HD. But from a technical perspective, as long as you fit within that 19.39, you get that, 1.2 megabits per second, let's just say, is that possible? Could you start up converting all those to 720p and keep the same bit rate, just compress it a little bit more? And what's that trade-off in visual if it's a higher resolution, but it's just slightly more compressed versus a lower resolution, but it looks better?
We can play the games. All these, the key is then you need the station owner to be very careful because we don't know what channels they are deploying. So we build a generic statmux, right? And we give them the handles. Gotcha. The problem is they need to tweak those handles, sit there and tweak the handles, and they can do it. Frankly, they just paid some attention because we are not able to see what their video quality looks like on their channels in that location, that market. So we just give them general directions. We give them general directions on how to tune it. But you're absolutely right. If you tune those channels very carefully, if you knew the nature of your channels, we give you the average peak. We allow you to set the average peak and the resolution and the frame rate. All of those you can tweak for each channel. So when they sit there and they tweak those channels, right, they can get it down to a point. You're absolutely right. You can squeeze in more for slight loss in quality, which everybody may think is fine, but we don't quite control that at each station. So we have 600, 700 stations where people just do their own thing. And the bridge is something that we just saw, you publish it. We are seeing that for the first time. We have no idea what is going on out there in the field because we don't control it. We just give them all the handles and then it's really a software encoder. If you think about our encoder, it's running on servers and GPUs and it is completely flexible. It was all written in Linux. So it's a pretty flexible platform that station owners can tweak. And some station owners sit there and tweak it ad nauseum. They look at the quality and really get it down pretty good. Some don't. Some don't care. They just set it to default and leave it there and keep running.
So let's just say there's no technical limitation with your product to have 15 720p channels with stereo audio as long as it fits
if the quality supported it. If the quality is supported, the answer is yes. But I doubt you can get 15 and 19 megabits trying to do 1 megabit channel, because if you did 15 channels, right, you have to have 15 megabits of video. Yeah. Now you have to add audio on top of that and piece of data on top of that. So you'll go above the 19. So you may be lower than that, than 15. But you know what? People have to try. They have to see what the quality of their content is and try and be satisfied with what they need. So,
well, and there's also, definitely.
I'm just going to add, what you probably observed also is that since Bridge, I think, is running 16 channels or 17 or something, the statmux has got some breathing room, and so it's going to use every bit. It's not going to throw nulls in there. So, it may have been running at that 1.1 or whatever, but only because it didn't have enough to do. So
actually. Yeah, so when I did the TS reader, I think it had 14 channels. There was about a megabit of null packets, but then they added another channel on. So I think they were expecting that.
They were working, yeah. People are constantly experimenting with this type of thing, and it's too easy to do that. It's easy, almost it takes you 2 minutes to add a channel or remove a channel, and do it on the fly. So people have been playing with it a lot, actually, especially with the 264 when the channel count goes up. And so there is. The other aspect of this is, remember, the first channel in the case of the Buffalo station, the first channel is always MPEG-2. So they are running one HD channel at MPEG-2, which is eating up a lot of they put a lot of bits towards it. And then the remaining channels is whatever they get, right? That's what they do. And everybody is doing that because I think there is a requirement, the FCC has a requirement that your first .1 has to be an MPEG-2 channel, is what we have read. Our understanding of the FCC is that's what you have to do.
But it doesn't have to be 720p, which is what they were doing, eating up 5 megabits per second.
That is correct.
If
you could do an SD MPEG-2 and then do all that.
I know.
We have suggested that, by the way. We have suggested that to some of our customers. I mean, they have to do what they have to do. The .1 is more valuable and they have contractual requirements to do certain things. That's why they do it the way they do it.
So. That's the biggest thing. I know I just want to touch briefly on what, Weigel was doing with HEVC with ATSC 1.0. Have you guys been getting into, I mean, it's a software product, so in theory,
Yes.
it should be able to.
We have actually experimented with doing HEVC. I mean, obviously, since we developed an HEVC encoder for the ATSC 3 market, we said, hey, what happens if you stick that codec into a 1.0? It will be fine. It'll work fine. The problem is, where are the receivers for it, right? How many television sets can actually receive it? And that's actually the limitation. So we decided in the marketplace, we talked to some customers. I mean, they were queasy enough with H.264, HEVC. They were like, nah, we don't even want to put it on air like that. So, and it's not standard. It's not supported by the standard. H.264 is. So
that's actually a good segue to my next topic, which is VVC with ATSC 3.0. So in a lot of ways, VVC is H.264 of ATSC 3.0 because it's now officially part of the standard. It's not like, oh, it's part of the standard for Brazil. It's like, no, it is a part of the standard. So the worst thing that I am thinking of right now is, oh my gosh, same thing's going to take place as H.264. It's going to take 20 years for VVC to ever get off the ground. You guys 20 years in the future are going to be telling people, please do VVC.
Oh God. I hope
so. I'm just curious with VVC, with your implementation, and if you guys have been working on that at all, and also LCEVC with HEVC, because that's a way to cut down on 35% without that computational complexity of VVC.
VVC, yeah, sure.
Yeah, so we have it running in the lab, but like Kumar said, because there aren't devices that can receive it, our customers obviously are not wanting to try it. But in general, yeah, it's a very powerful codec, and would love to use it, but unfortunately we've got big chicken and egg problem there.
The other side of this is, right, from a commercial perspective, the cost of doing an encoding gets really within the realm of being real when it is done, in today's environment. It gets really cost effective when it gets put into a GPU. So when NVIDIA or Intel in their GPU platform, they have, I don't know if you are familiar, NVIDIA and Intel both have a hardware pipeline for doing video encoding and decoding. In hardware. This is other than the CUDA cores that they have for computation, other computational stuff. This is hardware pipelines. So today they support H.264. They support HEVC. They also support AV1. Actually, Intel supports AV1. Eventually, I mean, within a year or two, my bet is they will support VVC. And our belief is that when they do that, then it becomes really cost effective for us to use that acceleration to develop a VVC products. Otherwise, the CPU, if you're putting it on a CPU platform, the cost is too high. We need a very, very high-end CPU to do a single channel of VVC. So until that hardware acceleration becomes available, we may not even think of deploying it, even if people start to talk about it a lot. I mean, we'll obviously be experimenting with it, but the acceleration platforms need to be available for us to commercialize it, put it in out there. And we expect that to happen in the next year or two.
Gotcha. What about LCEVC as an extended layer?
It's interesting that you bring up HEVC. We actually developed with an Israeli company about 6-7 years ago, exactly extending HEVC. We did a low complexity extension, scalable extension to HEVC, which we actually tried to standardize within the same standards body, which we never took too far. But we have spent quite some time developing, because that particular product that we developed, this was with a company called Novelsat. Actually, we were the codec providers and they provide the satellite modulation. This was married with a more efficient satellite modulation as well. And the reason we did that, the whole project, this was a joint Israel-US project funded by Bird. And the reason we wanted to do that was they were thinking that there will be mobile handsets receiving off of satellite at that point. And that was the reason why we developed that entire project, because there would be a scalable, low complexity extension that can be received with very low power on a handset. And that was that extension that we developed. Unfortunately, we kind of, the technology worked. We had technology demonstrations of it. And then the low complexity HEVC standardization body went a slightly different route. That the standard that finally got developed was a slightly different, path into achieving the same goal. And so we haven't implemented that in any of our products today. We did the other version, but not this version. But I believe that there is a value, especially if you think about Starlink or somebody starting to carry video and it showing up in mobile handsets, then there is some value to these kinds of extensions becoming more popular.
Well, and I think too, from a, because, I was talking to, Jeffrey privately a few days ago, and I was getting into the fact that these ATSC 3.0 set-top boxes, they can't software decode VVC because they just don't have the processing capability. And I brought a prop with me, and I'm going to show you in a second that this $60 cheap Samsung phone can easily. But the thing is, a $150 ATSC 3.0 box can't. But what it could do with software, with a software update pushed out from one of these vendors, is an LCEVC, addition that would cut the bit rate down upwards of 35%. And that would be a way to like do an intermediary bitrate savings from jumping between HEVC and going full force to VVC, kind of be like an in-between data savings to make 3.0 more efficient right now. Because
what I don't know is whether these set-top boxes, usually they are built on a chip, and whether these chips can use a software update. They usually have a hardware pipeline to do most of the decoding. Whether they can do with a software update, whether they can support the low complexity version, I just don't know. I mean, I don't know what chipset they're using. If it's an ST or usually it's an ST or a Qualcomm chipset that's sitting there, and I don't know whether they support such software upgrades or not. But you're right. I mean, if they could, then it does make some sense to, and especially if a phone can do it, that means there is a chip out there that can decode it. So they should be supporting it with that kind of a chip in the set-top box, then, right? I mean, that does make some sense.
Yeah, I just think, when I think about it, HEVC came out in 2013. I'm 21 years old. So for me, it's been around for the majority of my life. So for me, HEVC is an old codec.
That's really funny.
So, I mean, so when I hear people saying, HEVC is so great, I'm like, yeah, but it's also from 2013.
Yeah.
We could be using, 2020 technology, LCEVC, which is, I think, even newer, but wouldn't require the complexity and not have as good of a savings, but still be an intermediary. So when I think of this, I'm like, is this the direction that we really should be going in? And unfortunately, it's being decided right now by these low power, cheap plastic boxes that cost way too much, that do DRM and do all of this stuff with ATSC.
Well, that's a different discussion altogether, right? Whether there should be free-to-air television should be gated by DRM is a completely different question. What percentage of that can be gated is yet another question which the FCC has to decide.
Of course.
Yeah. So
jumped a little bit ahead of myself there, but
no, that's an interesting discussion as well. So
yeah. So I'd be curious just to show you. I know it's via Zoom right now, but this is an app. This is a VVC decoding software decoding application that a genius guy came up with. Very simple to implement on any Android phone, and this is absolutely incredible. So this is a combined average of 42 kilobits per second with VVC and mono XHEAAC. So it's 6 kilobits per second, constant bit rate for the XHEAAC, and then it's on average 36 variable for the VVC. And I'm curious to show you, this is what you can do in 36 kilobits per second with audio and everything. And I mean,
do you know what frame rate it's running at?
Yes, it is 30 frames per second. I can bring up some technical information here. It spits out a whole, I could send this to you. I can screenshot it, send it to you. But it is incredible. And when I've tried it with HEVC, it won't even go below like 60 or 70. And it's just a blob of like gray blobs.
Yeah, sure.
So it is a fluid moving image of me that you can discern like with the human eye. This is a human that is talking right now. You can see the mouth moving. And it's at only 36 kilobits per second. So it's, I mean, does it look highly compressed? Of course. But is it at least like watchable?
It's watchable. Yeah, sure.
And
this is why the scalable, the scalable formats were developed exactly because of this. You pick up the lowest, scaled version of if you wanted it to look blocky, but at least watchable, right? That's why the scalable format was developed. But you're right. I think there should be variations of this that should be not changing once every 10 years, but we should be able to upgrade every couple of years. And that way you get the latest technology. You're not waiting for 10 years or a 15-year cycle to change codecs, but that codec changes. We should be able to do those. Given that we have GPU and we have very powerful hardware on the phones or on any device, these things should be changed every couple of years, 2 to 3 to 4 years, and get the gains. I agree with you, completely agree, in agreement with you. This is why we left our day jobs to start a software company, because we thought this is exactly the direction where the industry should go. This happened to audio, by the way, back in the 90s, before you were probably born. Then in the 90s, audio completely switched over from being a hardware. I developed switches back in the 80s, big switches, right? Audio switches. And then in the 90s, all of a sudden, everything was running in software over IP. I mean, it started to run over IP. I'm like, man, this is all software now. Why audio is nowhere in hardware anymore? Same thing happened, should have happened to video. It's still happening, not yet happened. I think
well,
that's...
and the cool thing with the VBC implementation is that one, yes, it is a long startup time if it was a long, if it was a live stream. But I did a version with a GOP of, what is it, 16 milliseconds, and it was 50 wow. kilobits per second. So slightly more compression, slightly doesn't look as good. And this was 360p. But again, it is discernible. Like you can tell on the screen that something's happening. And to me, it's just mind blowing. So, and then the other one I did, 250 milliseconds was the main one. And you could actually, it wasn't a huge blob of pixels. It was more consistent. And if I were to implement something like this at a broadcast site, I'd probably do the 250 millisecond variant so that it would look at least borderline watchable. But still very good results with this. And it's honestly mind blowing. It was done with software encoding, very, nothing incredible. It wasn't 2-pass encoding. It was just 1 pass, spit it out, get it done. And it was able to do it. So to me, that is incredible. And it's kind of why, I want to move in the direction of receivers that are, mobile devices, or at least devices that are powered more, because I feel like the future of broadcast should really be receive devices that are adaptable. And I brought this up with Jeff, with what Steve Jobs said with the original iPhone, which is, when smartphones at the time had plastic buttons for, the keyboard and the number pad, Steve Jobs up on stage said, if we wanted to, with a software update, change what was on the keyboard, we couldn't do it because it's like permanent. It's a permanent feature of the phone. Whereas with a completely full touchscreen device, it's, completely adaptable with software as long as the, underlying hardware can support it.
The problem with them is really sort of in the bottom 40 there. It's this stuff right here. They all have these keyboards that are there whether you need them or not to be there. And they all have these control buttons that are fixed in plastic and are the same for every application. Well, every application wants a slightly different user interface, a slightly optimized set of buttons just for it. And what happens if you think of a great idea 6 months from now? You can't run around and add a button to these things. They're already shipped. So what do? It doesn't work because the buttons and the controls can't change. They can't change for each application, and they can't change down the road if you think of another great idea you want to add to this product.
And that's, I think, what should happen with this stuff. And I'm seeing some really good, especially battery results with VBC at much higher bit rates and upper resolutions. This thing can't do 4K. It maxes out at 1440p, but this screen is only 1920 by 1080p anyway. So there's not really a point. But this is a $60 phone, and I think it's just incredible that, all of this can be done.
No, we totally agree with you. I think the applications, right, are not necessarily even keeping up with the hardware revolution. The hardware revolution is going at a pace where the software is still falling behind to keep up. Like, I think, and all of this goes into software, and the software adaptation rate needs to keep up with the hardware, the rate at which the hardware is improving. So I agree with you. Yeah. That's probably one of the challenges of the industry and, of the broadcast industry too. So,
yeah, for sure. If you guys want to get into data carousels at all, I think that would be a very interesting topic that a lot of people don't fully understand.
So one of the challenges of broadcast itself, right, is one-way broadcast. So a lot of times for data, you unlike video or unlike other unlike audio or video, data needs to be error-free. The challenge of making something error-free is, in a broadcast world, especially when you don't have feedback, so you can do one of two things. You can put what is called matrix. There's many ways of coding the data so that even if you had error in one block, you can use an adjacent block to error correct it. You can do what is called fountain codes, which are like a way to progressively correct errors as you go along. There are many techniques that people have developed to do one-way broadcast carousels so that the endpoints can over time correct for errors that because there will be errors, because going over the air, there will be errors due to interference, due to multipath, whatever. So these errors can be corrected if you had and you build a set of tools to do your error correction. So data carouseling, one of the challenges with data carouseling is that if all these tools that you put in place to do the error correction of a particular block failed, you want to get another swipe at the data later on, because you can't have any errors. Essentially, if you're trying to do a software update, for example, you have to have an error-free reception. Only then you can use that block of data. Otherwise, the block of data is useless, right? Until you are able to fill it in with a corrected error block. And by the way, the correction is constantly monitored by all kinds of redundancy checks, 1 and 2 dimensional and so forth. So the challenge with data carouseling, and this is something that many people have not quite gotten their grip into, is that the capacity of doing data carouseling is a function of where you are in the infrastructure. Like, for example, carouseling in Phoenix would be much simpler than carouseling in Utah for the very reason that in Phoenix, everybody is like, it's a flat infrastructures. Put up an antenna, you'll receive it pretty reliably. Unless there is a bunch of interferers, you're in great shape. You go to Utah, which is nearby, not too far off, hilly terrain, half the time you miss data, especially if you're mobile, you miss a lot of data. And so carouseling means you have to have many more, the carouseling parameters have to be completely changed. So the throughput, right, of carousel data on broadcast changes depending on where you are. And so that's one of the biggest challenges for planners, for people who are planning, like let's say if Tesla says, I'm going to do a software update across the country using a data carousel from ATSC 3, the challenge that they have in a broadcast infrastructure is they'll cover 90% of the population in Phoenix, but only 60 for the same carousel parameters in Utah. So then the question is, what do they do? So for Utah, they would have to redo the carousel over many more times, which means that it's less efficient. And so this is one of the biggest challenges of broadcast carouseling as an application. There are other carouseling applications where it's easier to do, like distribution of education content and all, because those are regional. So they can tune them regionally. But whenever you have a national application, it becomes a lot more challenging.
So would you say that as a rule of thumb, if the area becomes trickier, you lower the modulation encode rate to make it more robust, and then make it go longer?
So you have the two handles, right? You can lower the modulation coding rate, which means your throughput goes down. And so you'll have to do lesser number of carousels to get your 100% coverage. Or you say, I'm going to carousel it more times. I'm going to leave the modulation the higher, and then I'm going to carousel it more times. A third alternative is that anyway, cell phones have a return path. They may go and fetch the missing data over a back channel somehow. They can do that too. So there is software that is being developed to do both, all of the above. And so overall, right, the robustness of adding these software layers on top to make sure you get 100% reception of all the data is the biggest challenge. And a lot of companies have spent a lot of time doing this. It's not a trivial problem, especially when you're trying to solve it for a broad set of geographies with very, very different conditions.
Yeah, and with software, you can ensure that when it does display as a full complete file on the device, that it is like error-free.
It is error-free.
That's what, coding algorithms are for, to make sure that, if there were any errors, it rejects the whole file, or if it's done in segments, that it, rips out that segment and waits for it again.
Sure.
So it's not like, oh man, if I do data casting, it's going to be this file that's going to brick my software device, and some people have that, perception like, oh, it's just unstable. It's UDP. It's just going to, And it's like, no, at the application layer, it's going to go through
Absolutely.
and ensure that that file is the
Right.
quality is there.
And it is getting it over, like I said, the carousel, there is your three handles, right? The modulation coding parameter, like you said, they can just,
Yeah.
that can automatically be adjusted to improve reception. The number of times you carousel something. And then on top of that, you do all kinds of CRC checks and everything, and you have a back channel. If you needed to go back and fetch a segment on a back channel, which is low cost because you have done only a small segment, you can do that
Yeah.
in addition. And so tools are there to do all of the above. So
And two, with ATSC 3.0, there's also, spatial multiplexing. There's MIMO. There's layered division multiplexing. So you can in turn allocate more data capacity
Sure.
to, your data carousel than you normally would with a SISO or without, multiple services without a layered approach.
Yeah.
So, that's a great thing as well. It's like, oh man, if I make it robust, I'm not going to, you could double your data capacity if it's robust
By doing
with
MIMO.
MIMO, or ensure that, you're getting the full data capacity with that tier with LDM with just a small impediment on the receive SNR. So it's
Yeah.
a great standard for that. And I think that's one of the things that 5G broadcast doesn't have on
That is
ATSC
true.
3.0 is
That is true.
LDM.
Speaking of 5G versus ATSC 3, you're absolutely right. ATSC 3 is slightly better designed for doing broadcast carouseling. This is something that was by design, actually. People from
Yeah.
day one decided that they wanted to do that. The only flip side of the whole story is the 5G world. I mean, the infrastructure, especially the not only the phone infrastructure, but also phone infrastructure with an extension to receive UHF, but also the transmit infrastructure. So imagine that all the cell phone base stations now all of a sudden can become 5G transmitter sites
Yeah.
with a small modification. The 3G using the ATSC infrastructure is slightly stymied in terms of the number of, where the infrastructure lies, right? The overall, how it overlays the geographies is very different than what the cell phone infrastructure is, which is one of the reasons why 5G, if it has the right, it is slightly less efficient than ATSC 3 for those kinds of broadcast carouseling applications. But the thing that works in its favor is this head-end infrastructure, and also the fact that phones can be modified a little bit more easily. I'm not saying it's easily, but it can be done. That's one of the things that it has working in its favor.
Yeah. Yeah, for sure. There's actually a discussion that I just watched earlier today with Mark Atkin and a few others from the NAB that was discussing about possibly either interleaving or putting 5G broadcast on a PLP. It's interesting because I had just talked to Frank Kopasidis, and he said that it wasn't possible. At least that's what he was being told. And then at the NAB, they were saying that, it was possible as an option. So there seems to be some disconnect as to, what the actuality of
That's doing a little, that's fitting a square peg in a round hole. Actually, that is not the intent of either of these standards. Was to address what they were doing. One was trying to address point-to-point communication. The other one has been explicitly designed for broadcast. So I think they should, leverage their strengths and not try to fit one into the other. That makes it just more complex and adds more complexity for no reason. So I don't have a bone to pick in this, because as a company, we want to deliver video. So we don't care whether it's 5G or ATSC 3.0 at this point. From the RF point of view, we are happy to support both standards, and we are like, hey, bring it on and bring on VVC. I think it makes the most sense for us.
Yeah. If Jeffrey wants to talk about that a little bit at the compression side for.
Well, yeah, as Kumar says, we're ready to go with HEVC, VVC. We'd love to. I mean, we could just be able to do more, just better pictures, more channels. It's kind of a shame ATSC 3 right now has this capability of doing 4K, right? And 4K TVs are pretty widely spread at this point, and there's not very much content out there. And then on top of it, because the ATSC 3 chicken and egg problem, they're basically just broadcasting in HD. So we feel like, this ATSC 3 great standard and all the capabilities in it is just handcuffed because we don't have the TVs. And so, I can tell you, Kumar and I lived through the early days of the MPEG-2 being developed 35 years ago, and we're still making products that
This is
make
a big part.
MPEG-2. I can't believe
Yeah.
if you had told, Jeff and Kumar, the young engineers in 1995, you're still going to be making MPEG-2 products in 30 years? No way.
We wouldn't have believed it.
No way.
Unfortunately, that's where we are. So
Yeah. I mean, H.264 was a standard, right around 2000, I think.
yeah.
25 years. 25 years.
Yeah.
It just last year we got somebody to put it on there. So it's we're all as engineers frustrated with, wow, we could be doing so much more, but there's the whole,
The
business,
reality of the market, right?
the market side of it, the business side of it. So as Kumar says,
Yeah.
we'd love to see 5G and ATSC 3 succeed. Expect that would open up the use of these other codecs. That would be great. But in the meantime, it's an ATSC 1, H.264,
What?
world right now.
Yeah, my last question for you guys is, do you see ATSC 1.0 sticking around using more efficient coding, or do you see it going the direction of just ATSC 3.0 all the way, or a combination of 3.0 and 5G, 3GPP standards?
Yeah, I can't predict what's going to happen at the FCC with ATSC 3. There is an effort to try to find a way to sunset ATSC 1 and move more forcefully towards ATSC 3, but I know that unless they have a solution to the TV problem and being out there, that will really impact, viewers.
So mandate is what we discovered was analog to digital transition. The mandate from the government is actually what forced people to switch, broadcasters to switch away from analog to digital. And there was one other thing that happened at that time, which was HD. People like to watch their content in HD. So HD was a reason why people were willing to switch to digital, okay, from going from standard definition. The jump from HD to 4K is not as dramatic unless you do things like multi-view, or you do this HLR, I mean, whatever, high resolution, video. Huh? HDR,
High dynamic
HDR.
range.
High dynamic range. Yeah, the higher dynamic range video is definitely a good use case. That hasn't taken off. So I think consumers will switch when they see a perceptible difference in something, right? Either more content or better quality that they can actually see and experience. I think that changes people's habits and to switch. The other one is a mandate. So in this case, I suspect that only a mandate will force the sunset of ATSC 1.0 and force people to switch to the 3.0 world and get all the benefits. Otherwise, this will just drag on for another decade, right? With all the entrails of MPEG-2, MPEG-4, everybody will just keep dragging it along. I think that's what will happen in the industry.
Yeah, I think my consensus for what I would imagine to be the perfect future for broadcast would be ubiquitous broadcast support on as many consumer devices as possible.
Totally.
Consumers not having to go out and buy a specific device just for broadcast capabilities, and showing the consumer you can get 4K HDR NFL games or sports or this or that, like really high quality content that the consumer wants to watch, not just 480i infomercials, but HDR, high quality sports and things that like people actually want to watch. And that's a different discussion, but that's very important to this. And ensuring that broadcast doesn't continue to be plugging in an external bulky antenna to an F connector on a box or a TV. I made the joke with Jeff with a previous discussion with him that kids these days, people my age, they're not sticking in a dongle with a telescoping antenna to watch TikTok videos. So, if you want that mindset to occur with people of like, this is just like any other thing that you utilize, this is as modern as your TikTok experience, as your YouTube experience, you incorporate it directly in the phone. We have the technology to do that, obviously, but it's just whether or not we get there. And I'm, part of my YouTube channel and part of my push is to push the industry in this direction, more of a modern scenario.
You're doing a good job.
Thank you so much.
Absolutely.
So
We recognize that this is what
That's the
know,
future. Yeah.
Yeah.
that's what people watch
That's where
more and more. That's what people are used, and even us olds, as my kids say. I watch some TV on my phone, and the younger generation than me, anyway, certainly does. So that should definitely be part of whatever the future holds.
and I think it's great. Yeah, I just want to interject that the Apple patent situation is a really cool opportunity for broadcast as well. I'm not sure if you guys have heard of the Apple Pencil patent to incorporate broadcast capabilities. And Frank had mentioned a really good point that Apple doesn't have any CDN infrastructure right now that's truly their own, and that a wireless multicast model could be, in a very modern implementation of it, a possibility for them. And the fact that they're even recognizing with a patent that there is a good use case for this is, I think, really cool. And I personally love Apple. Kids in middle school and high school used to call me an Apple sheep because I would buy all the Apple products and everything. But, I think it's a great company, and I hope that there's a future with that, because, that would be a really interesting opportunity and an interesting take on broadcast. Very thinking out of the box, using a stylus as the means to, send it and then send it to the device over Bluetooth.
Sure. Yep. Cool.
interesting.
Very cool. Thank you very much, Dylan.
Yeah, if
For the
my
opportunity.
audience wants to reach out to you guys, or are interested in any
feel free.
equipment, where should they contact you? And
So www.igolgi.com and info@igolgi.com. I mean, that'll get to us, and usually we are fairly responsive. We are based in Chicago, and I'm in New Jersey. Jeff is in Vermont, and all our team is in the US. So that's another big plug for igolgi. We are an American company built with completely American team, and so they all are very familiar with all the nuances of broadcast, and they all live in different parts of the country too. So we eat our own cooking, so to speak.
yeah, and US manufacturing too, which is really
yes, absolutely.
I love everything.
We do everything local, and we are a software company too. So if you think about it, we're a software company. So all our development happens here. So wonderful.
Well, it was a pleasure having you guys on. It was a pleasure to talk to you guys. Hopefully we can do it again sometime. Maybe when there's a mandate.
Dylan, you do a wonderful job. We watch all your videos, by the way.
Thank you very much.
Awesome.
Thanks for what you do.
I appreciate it. Thanks, guys.
Thanks, Phil.
Bye.
Talk to you soon.
Bye.